Good day everyone. For this video of pre-calculus conic section with regards to hyperbola, we will have our final topic which is all about identifying the properties of a hyperbola. Always remember that there are two orientation of the conic section for the hyperbola, which is the horizontal and the vertical hyperbola. So let's practice and use this first example to find the different properties that we need in graphing or identifying the parts. So the equation would be given is x plus 1 quantity squared over 9 minus quantity of y plus 2 squared is over 16 is equal to 1. So I already prepared all the necessary equations and parts that are needed in finding the properties of a hyperbola. First, let us identify the orientation. Since on this particular given, the value of our variable or the variable that we use on this first part is x plus 1 quantity squared over 9, and we can see that the variable x is the first term. We can assess that the orientation is a horizontal hyperbola. So we will write horizontal. Number 2, a squared and b squared, which are 9 and 16 respectively, because the hyperbolas value of a squared and b squared will never change position when in terms of the orientation, regardless if it is a vertical or a horizontal hyperbola. So number 4, we need to find for the value of a, which is 3, 5, its value of b, which is 4. Just get the square root of 9 and 16. Number 6 is c is equal to square root of a squared plus b squared, where a squared and b squared come from the horizontal hyperbolas equation. So that would be 9 plus 16. So get the square root. The answer would be square root of 25, and square root of 25 is equal to 5. So we need the values of a, b, and c, or a and c, to give the coordinates of the vertices and your focus. So for number 7, we can now get our transverse axis using the formula of 2a. So 2 multiplied by the value of a, which is 3. So that would be 6 units. So don't forget the term units. Number 8 is your CA, conjugate axis, which is equal to 2 times B, which is 4. So that would be 8 units. Number 9 is your center, which is negative 1, comma negative 2. And finally, we can now have our vertices V1, which is H, which is negative 1, plus the value of A, which is 3, comma 4, negative 2 instead. So the final answer would be positive 2, comma negative 2. And for your V2, just change from plus becomes minus, and that is negative 4, comma negative 2. Lastly, for F1 and F2, same process, but this time we will get or use the value of your letter C to be added from our H. So negative 1 plus 5, comma negative 2, and negative 1 minus 5, comma negative 2. The answer would be positive 4, comma negative 2, and negative 6, comma negative 2. So that is all your properties, or those are all your properties for our first example, which is a horizontal hyperbola. The next example is determine the different properties of the hyperbola given the equation y minus 1 quantity squared over 36 minus quantity of x minus 2 squared over 25 is equal to 1. So, let us go to the next slide. So, as we can see, I already prepared all the properties equation or solutions. And on this particular given, we can see that the numerator becomes y minus 1, or the y variable comes first for our first term. So, we can now assess that it is on the pattern of the vertical hyperbola. So, we will write vertical. Number 2, we can now have the values of a squared and b squared. Still, the denominator of the first term is your a squared, which is 36, and your b squared, which is 25. For number 4 and number 5, a and b are 6 and 5 respectively, and your number 6, letter C, is equal to the square root of 36 plus 25. So, square root of 36 plus 25 is equal to 61. Okay? So, on these options, there are different ways to write your answer. So, you can write square root of 61 as your final answer for the value of C, or you can write it into decimal, which is equal to 7.8102 for decimal places. Continuing on our properties, we can now find for our values or the length of our TA conjugate transverse axis first, and number 8 your conjugate axis. So that would be 2 times 6, 12 units, and CA, which is 2 times 5, that is 10 units. So for number 9, we have our center. Be careful on finding the center of a vertical hyperbola because the numerators y and x interchange their position. So always remember that the variable h would be together with x and the variable k would be together with your y. So since negative is the sign of the 2, we will write 2, 1 according to the rules that if it is positive, it will become negative. Continuing, we will have our vertex 1 on our hyperbola that is horizontal. We add a to h, but this time we will add it on our k value. So it will become 2, 1 plus 6. So that would be 2, 7, and 11 would be V2, 2, 1 minus 6, and that is 2, negative 5. For number 12 and number 13, we have foci 1, again, plus C, but this time with our K again, plus square root of 61. So this can be your final answer. And for F2, which is 2, 1 minus square root of 61. You can write your answer in the radical format, or you can simplify or convert your answer in decimal format. Still, for decimal places and 1 plus square root of 61, the answer would be 2, 8.8102. And for number 13, we have 2, 1 minus square root of 61, and the decimal format of it is negative 6.8102. And that is all your properties for a vertical hyperbola. So, on this slide, I am showing you now on how we get the properties of the hyperbola. So we have the value of 2a, 2b, center, vertex, focus, transverse, and conjugate. I did not write or put the values that we need, such as a squared, b squared, the values of your a, b, and c, I just simply put the Pythagorean identity for the value of C, of a horizontal properties. The same with the vertical property. As we can see here, they have the same solutions or values for your relationship between A, B, and C, the transverse axis, conjugate axis, and the center. So I did not write again the values for A squared, B squared, then A, B, and C. You can get that using the denominators of the hyperbola. And then, as we can see on the standard equation, the position from a horizontal to vertical hyperbola are changed on the numerators. So y minus k first before x minus h, and then it affects also our vertex. Instead of adding a and c on our h variable or h value, it is added now or subtracted to your variable k. So that's all for our hyperbolic equation and the last conic section of the pre-calculus.